Hi, I'm Will, a researcher at Lancaster University on the AI4ME project, and I'm going to be telling you how AI4ME is tackling the challenges associated with large-scale personalised media delivery. It's worth noting the really big differences between personalised media and the traditional media you might already consume on things like BBC iPlayer. With iPlayer content, you're streaming a video file that already exists, and everyone else is streaming the same video file as you, the same episode of Strictly Come Dancing as you. Whereas with personalised media, each individual person could be consuming a completely separate, unique piece of content, which it might just be edited in a really small way, but unique nonetheless. So to actually show how the AI4ME flexible compute system works, we've developed a virtual network testbed, which contains data center resources and edge node resources that someone like the BBC may have access to when deploying an object-based media delivery pipeline. Each resource in this virtual network has access to the sort of stuff you'd expect to see in a real system. So the data centers have access to a bit more compute power, and the edge nodes generally have access to a little bit more I/O operation power. But the network connecting them is also kind of deployed in some realistic manner. So the edge nodes have better connectivity to the actual clients, and the data centers where most of the core compute would happen. And this graph here just shows the live activity of what's happening on this network at this time, and we can play around with the actual kind of layout of this network however we want to. And to show how this actually works for AI4ME, we've deployed the object-based media delivery pipeline onto this virtual testbed here. And as you can see from this screen, we've got the different clients which are all streaming directly from this virtualized data center edge node setup. The clients you can see on this screen are all using object-based media, which basically means you can consider each part of the scene an object. So the presenter, the map, even the time in the corner, all separate objects being delivered and compiled into a single video feed when you're seeing it. This is then reflected in how we deploy across the network, with each different component being read in a separate fragment. This is just shown in this display with all the different letters we can see in these boxes. Another thing this display also showed us is where in that virtual network we deployed each one of these fragments. Right now, network conditions are great for object-based media delivery streaming, so most of what can be actually rendered on the screen and what's being rendered in this cloud environment can all happen on these edge nodes that we can see here and on the core metro nodes, because we can all feed right through to it. The bandwidth is good, the latency is relatively low, so we don't have to really worry about the network conditions. Another benefit to the good network conditions is you can see the reuse percentage here is quite high. What this means is that we can actually reuse the cache that's been on these independent fragments, so we don't have to deploy as many of them to serve the same number of clients. This is really useful in use cases like the weather here, where actually most clients are streaming the same content. However, network conditions are not always good for object-based media streaming. So if some factors such as the bandwidth were to reduce between the clients and the data center, and for example, the latency might drastically increase as well, which has just happened now, we can actually see that resources and these components that feed into these clients are all having to move around in this cloud environment now to self-optimize to make sure that it can always deliver the same end user experience to the client, regardless of how they have to deploy it in the actual cloud environment. So deploying these across a wide space might be a little bit more costly to the provider, but in the end it means that even if network conditions do deteriorate, a self-optimizing smart orchestration pipeline can still deliver the same end user experience for the clients. So with this testbed, we've been able to show that we can synthetically degrade network conditions in an object-based media delivery pipeline, yet due to smart orchestration, we can place resources on central and edge nodes to make sure that the end user still maintains a really high quality user experience, even when network degrades. That might come at a small cost to the actual provider at the time, but obviously the main goal is to make sure that the end users can always have a good experience. And primarily this is leveraged cache reuse. So we've been looking at being able to make smart placement decisions based on what cache currently exists in those locations, and combining that with the actual network conditions such as bandwidth and latency at the time. And further on into this project, we want to look into how we can also try and make smart placement decisions based on stuff like which GPU hardware encoders exist in certain locations as well. So there's definitely more factors we want to consider, and that's what we're going to continue to do as we go further into the AI4ME project.